Closed loop control of synchronous motor. A typical characteristics of torque, current, and excitation voltage against frequency ratio beta as shown here. There are two regions, that is constant torque and constant power. In the constant torque region, the voltage is maintained constant, and in the constant power region, the torque decreases with the frequency. The torque speed characteristics for different frequencies are as shown in this diagram, which is similar to the induction motor. The speed of synchronous motor can be controlled by varying the voltage, frequency, and current. There are various configurations for closed loop control of synchronous motor. A basic arrangement for constant voltage control of synchronous motor is as shown here, where the speed error generates the frequency, that is omega s, and the voltage command Vd for the PWM inverter. Since the speed of synchronous motor depends on the supply frequency only, they are employed in multi-motor drives requiring accurate speed tracking between motors, as in case of fiber spinning mills, paper mills, textile mills, and machine tools. This is regarding closed loop control of a synchronous motor. Brushless DC and AC motor drives. Brushless drives are basically synchronous motor drives in self-control mode. The armature supply frequency is changed in proportion to the rotor speed changes, so that the armature field always moves at the same speed as the rotor. The self-controlled ensures that for all operating points, the armature and rotor field moves exactly at the same speed. This prevents the motor from pulling out of step, hunting oscillations, and instability due to a step change in the torque or frequency. The accurate tracking of the speed is normally realized with a rotor position sensor. The power factor can be maintained at unity by varying the field current. The block diagrams of self-controlled synchronous motor fed from a three-phase inverter or cycloconverter are shown here. For an inverter-fed drive, here, the input source is a DC depending on the type of inverter. The DC source could be current source, a constant current, or controllable voltage source. The inverter frequency is changed in proportion to the speed, so that the armature and the rotor MMF waves revolve at the same speed, thereby producing a steady torque at all speeds, as in a DC motor. The rotor position and inverter perform the same function as the brushes and commutators in a DC motor. Due to the similarities in the operation with a DC motor, an inverter-fed self-controlled synchronous motor is also known as commutator-less DC motor. If the synchronous motor is a permanent magnet motor or reluctance motor or wound field motor with a brushless excitation, then it is known as brushless and commutator-less DC motor, or simply brushless DC motor. Connecting the field in series with the DC supply gives the characteristics of a DC series motor. The brushless DC motor offers the characteristics of a DC motor and do not have limitations such as frequency maintenance and inability to operate in explosive environments. They are finding increasing applications in servo drives. If the synchronous motor is fed from an AC supply, it is called brushless and commutatorless AC motor, or simply brushless AC motor. These AC motors are used for high power applications up to megawatt range, such as compressor, blower, fans, conveyors, steel rolling mills, large ship steering, and cement plants. The self-control is also used for starting large synchronous motors in gas turbine and pump storage power plants. This is regarding brushless DC and AC motor drives. If this video is useful, please like, share, and subscribe.